In this video, we are going to be looking at how to graph a quadratic in standard form. Standard form is ax squared plus bx plus c, where a, b, and c are all constant values. It's important to note that a is the coefficient of x squared, b is the coefficient of x, and c is the constant term at the end. It doesn't have to be written at the end, though. You can see it kind of in non-descending order. However, the most important piece of graphing in standard form is being able to find the vertex, and that's where our formula for the vertex comes in. Rather than say negative b here, I like to say it's the opposite of b over 2a. So to find the x value of the vertex, we first have to recognize what our a, b, and c value of our standard form quadratic is. So in this case, even though I don't see a value in front of the x squared, I'm going to call a 1, b is negative 2, and c is negative 3. The formula to find the x value of the vertex is the opposite of b over 2a. Notice I say opposite of b. That reminds me that if my b value is already negative, I want the opposite of that in the numerator. So if my b value is negative 2, the opposite of b is positive 2 over 2 times 1. A value is 1 here. So I get 2 over 2, which is 1. This is the x value of my vertex. Once I have the x value of my vertex, I can substitute that back in to my original function. So my original function, f of x, or we want f of 1, is x squared minus 2x minus 3. But anywhere we see an x, we are going to place 1, which was the x value of our vertex. So we get 1 minus 2 minus 3, or negative 1 minus 3, so negative 4. That means our vertex is 1, negative 4. Again, don't feel like you have to do this mental math. If you are struggling, please use your calculator and use parentheses accordingly. So we can do parentheses 1 squared minus 2 times 1. Notice I put all my values in parentheses, and I get negative 4. Now, just like when we graphed in vertex form, we are going to pick two numbers that are bigger than 1 and two numbers that are smaller than 1. Please ensure they go in consecutive order. If they go in consecutive order, then we can use reflection to say, okay, if we know that this point is 0, whatever number, then this point will be 2 and have that same y value. So if I put 0 into my equation, 0 squared minus 2 times 0 minus 3, 0 minus 0 minus 3 is negative 3. That means the y value at 0 is negative 3. If we know that the vertex is at 1, negative 4, then the point at 0 and the point at 2 should be symmetric. So this should also be negative 3. Okay? You can choose to substitute in negative 1 or 3. It doesn't matter because they should yield the same result. But again, if using the negatives or working with negatives is not your thing right now, then we can do parentheses, negative 1. Notice I put my negative in parentheses, minus 2 parentheses, negative 1 again, minus 3. And I get an answer of 0. So this value is 0, which makes this value 0. I'm going to plot all my points. So this is the point, negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, and 3, 0. Again, things you want to make sure happen after you graph. The first is that you want to make sure it actually creates a U. The second is that you want to make sure that the points are symmetric on both sides. So you can see here, if I plotted negative 1, 0, that was 2 points off the x of symmetry. You should have a symmetric point over here at 3, 0. Other things you want to note, the A value here was positive 1, so this graph should be opening up like a cup, and it does. Also in standard form, it's pretty easy to see the y-intercept by just putting 0 in. So if you were to substitute 0, the C value is actually your y-intercept. So you should have a y-intercept of -3. Those are just a couple things to quick check your work. Let's do one more example. Again, if you need help answering any of these things, there is also a video on characteristics of quadratic graphs that you can watch. My next example, I can see A is -1, B is -8, and C is -12. So when I do the opposite of B, since B is +8, I'm going to take the opposite of that. Since B is -8, I'm going to take the opposite of that, which is +8, over 2 times -1. So remember, it's opposite of B over 2A. Since my B value is -8, it became +8. My A value stays -1. I simplify this, 8 over -2, which is -4. So -4 would go in my X column in the center of the table. To find my Y value of the vertex, anywhere I see an X, I'm going to replace with -4. Keep in mind that this negative out in front is like a -1 as a coefficient, so you cannot make it a positive by putting it in parentheses. That negative has to stay out in front. And then -8 times -4 minus 12. Again, if you want to do this part in your calculator, you want the negative out in front, so it's negative, then your parentheses, then -4 squared, minus 8 parentheses, -4 minus 12. And we get +4. When you look for other points, you want to plot 2 points that are smaller than -4 and 2 points that are bigger, as long as you go in consecutive order. So now I can do -3 in for X, and I can also do -2 in for X. And these values should match their symmetric points here. So the value at -3 should match the value at -5. If you put this in your calculator, you can also re-enter it. Maybe not. Oops, sorry. There should be a way that you can go back and just re-enter it so that you're just replacing the value. But we will type it out for right now. And we get +3. So if this value is 3, then this value is also 3. Okay, and then down here we get -4 plus 16 minus 12. So 12 minus 12 is 0. I should be looking, because the A value is negative, I should be looking for this quadratic to face down like a frown. And I want to make sure that the points that I have are in fact symmetric. And create a U-shape. Okay, that's it. Again, if you need help answering any of the characteristics, please see the graph of quadratic characteristics video.